Have you ever wondered what kinds of worlds exist beyond Earth? From lava-scorched infernos to diamond-encrusted giants, from frozen ocean moons to entire planets drifting through the dark void of space. Today, you're about to take a journey across every type of known and imagined world in the universe. This is not just a tour of planets. This is a journey through science, theory, quantum philosophy, and even science fiction made real. By the end of this video, you won't just know about these worlds. You'll see the universe in an entirely new way. This is Worlds Beyond Imagination. Let's begin with the most familiar type of planet, terrestrial worlds. These are rocky planets with solid surfaces, and they make up some of the most fascinating objects in our solar system. Earth, of course, is our home. It's the gold standard of habitability. It has a stable climate, flowing water, and a rich atmosphere. Mars is a desert world with polar ice caps and hints of a watery past. Beneath its dusty surface, there may still be liquid water and possibly even microbial life. Venus is the most Earth-like in size but not in character. Its thick carbon dioxide atmosphere traps heat in a runaway greenhouse effect, baking the surface at over 450 degrees Celsius. Mercury, closest to the Sun, is a dead world of extremes, blistering hot on one side, freezing on the other. It has no significant atmosphere. Despite their differences, these worlds remind us that small, rocky planets come in many flavors. Gas giants. Now, scale up. Way up. Gas giants like Jupiter and Saturn are mostly made of hydrogen and helium. They don't have solid surfaces, just layers upon layers of gas and liquid. Jupiter is a colossal world. Its great red spot is a storm wider than Earth that's raged for centuries. It emits more heat than it receives from the Sun thanks to gravitational compression. Saturn is known for its iconic rings, made of ice and rock, stretching thousands of kilometers but just meters thick. Both planets have dozens of moons, some of which may host life. And they're a window into how solar systems form. Ice giants. Further out lie the ice giants, Uranus and Neptune. Despite their names, these aren't frozen solid. Their interiors are rich in water, ammonia, and methane ices. Uranus is the most tilted planet, rolling along its orbit. It has faint rings and over 24 moons. Neptune is an active world with the fastest winds in the solar system, clocked at over 2,000 kilometers per hour. Its deep blue color comes from methane in its atmosphere. Ice giants may be the most common type of planet in the galaxy based on exoplanet surveys. Ocean worlds. Some of the best places to look for life in the solar system aren't planets at all. They're moons. Ocean worlds like Europa, Enceladus, and Titan have vast subsurface oceans beneath icy shells. Europa has a cracked, icy surface and may have more water than Earth. NASA is planning missions to search for signs of life beneath its crust. Enceladus shoots water vapor into space, a sign of an active ocean beneath. Titan, Saturn's largest moon, has rivers and lakes of liquid methane. These are alien yet familiar, cold yet active, and potentially alive. Lava worlds. Now, from frozen to fiery. Lava worlds are exoplanets so close to their stars that their surfaces are oceans of molten rock. 55, Cancri E, and K241b are tidally locked, one side always facing their star. Daylight temperatures soar past 2,000 degrees Celsius. Winds may carry vaporized rock to the night side, where it rains down and rehardens. These planets are the universe's most extreme furnaces. Rogue planets. Some planets wander the cosmos alone. Rogue planets have no star. Ejected from their systems during formation, they drift in eternal night. Some may be larger than Jupiter. Others, Earth-sized. Despite the cold, some might retain internal heat, or even subsurface oceans warmed by radioactive decay. These worlds are invisible ghosts, detectable only through gravity or chance. Super-Earths and Mini-Neptunes. Beyond our solar system, we find super-Earths and Mini-Neptunes. These are planets larger than Earth but smaller than Neptune, and they are the most common type found by Kepler and TESS. Some may be rocky, with thick atmospheres. Others might be covered entirely in oceans. We don't have one in our solar system, which makes these exoplanets a new frontier in understanding planet formation and habitability. Hypothetical and theoretical worlds. Carbon planets. Imagine a world made not of silicates and water, but carbon. Carbon planets may form in star systems rich in carbon and poor in oxygen. Here, rocks might be made of graphite and mountains of diamond. Oceans could consist of hydrocarbons or tar-like compounds. These planets are theoretical but based on solid chemistry. Some could even be habitable in a very alien sense. Antimatter worlds. What if there were planets made entirely of antimatter? If these antimatter worlds existed, they'd behave like regular matter, until they touched normal matter. The contact would release immense energy through annihilation. We haven't detected any such worlds, but the symmetry of the universe suggests they might exist in isolated regions. If we find one, it could change physics and power technology beyond our dreams. Plasma planets. A plasma planet is a theoretical object where the atmosphere is so energized that it remains in a plasma state, electrically conductive and glowing. These might exist around extremely hot stars, or as remnants of failed stars. They blur the line between planet and star. Studying them could reveal new states of matter and energy dynamics in extreme environments. Dark matter planets. Dark matter makes up most of the universe's mass. But could it form planets? Dark matter planets would be invisible to light, detectable only by gravity. If they exist, they might influence nearby objects in strange ways. Understanding these could unlock the biggest mysteries in cosmology, including the nature of matter itself. Dyson Spheres and Megastructures. Let's move beyond planets entirely, to megastructures. A Dyson sphere is a hypothetical construct built by advanced civilizations to capture all energy from a star. It could take the form of a shell, a swarm of satellites, or a ring. Some believe odd stellar dimming might hint at such structures. If true, it would be the signature of a Type II civilization on the Kardashev scale. Megastructures like Dyson spheres aren't planets, but they might become artificial worlds of the future. Science fiction and exotic worlds. 1. Multiverse worlds. Now we step fully into speculative territory. What if our universe is just one of many? The multiverse theory suggests infinite parallel universes exist, each with its own laws of physics. Some might have different constants, different particles, even different dimensions of time and space. In some, Earth may never have formed. In others, life evolved in ways we can't imagine. These worlds stretch the imagination and redefine our place in reality. 2. Simulation worlds. Are we living in a computer simulation? Some scientists and philosophers take this question seriously. In a simulated universe, everything we experience is code, a vast program run by advanced beings. If true, then entire worlds could be generated, paused, and reset at will. Simulated worlds could mimic real physics or invent new ones entirely. We may one day create simulations of our own, entire realities inside computers, populated by artificial minds. 3. Artificial worlds. Humanity may not have to settle for natural worlds. Artificial worlds are space habitats, built by intelligent beings, vast structures that could spin for gravity, house entire ecosystems, and last for millennia. Concepts like O'Neill cylinders or ring worlds show how we might live among the stars without terraforming planets. These are the ultimate expressions of engineering, taking our destiny into our own hands. 4. Mythological and fantasy worlds. Throughout history, humans have imagined other kinds of worlds. Mythical lands beneath the earth, floating continents, or heavens among the stars. While not scientifically real, mythological worlds shape our culture, inspire our stories, and push the boundaries of imagination. From Middle-earth to Asgard to the Hollow Earth theories. These worlds live in the collective dreams of our species. 5. Conscious or living worlds. Could a world be alive? Not just with life on it, but the entire planet as a sentient being? The Gaia hypothesis proposes Earth functions as a self-regulating system. Sci-fi extends this idea to worlds that think, feel, or even speak. Imagine a planet that births civilizations like cells in its body, a living cosmos in every sense. These are the most exotic and symbolic of all worlds, where science meets philosophy. From rocky shores to molten hellscapes, from ghostly drifters in the void to simulations running on alien computers, the universe holds more than just planets. It holds possibilities. We've only begun to discover what worlds are truly out there. But one thing's certain, the cosmos is richer, stranger, and more beautiful than we can ever imagine. Thank you for exploring with us.